Alright, voltage drop. Everybody, it always sounds real complicated whenever time somebody's explained it to me, but this is pretty much how I see voltage drop. I'm doing voltage drop tests and what it amounts to. So if you have, and why you have to have a load on it. If you have a wire, I'm not an artist, so, and it's got a corrosion here. If you don't have a load, this voltage flowing through there will go through here, and it's blocked here. So that whole wire is full. So if you test it, you have 12 volts and 12 volts. But if you take away this block, all this flows out, and so you only have this. That's your voltage drop. So to show it over here, just set this little circuit up and just throw it on here. So it's basically a resistance check with voltage. Turn on our meter here and turn it on to voltage. You got power on the battery, and you're testing through this wire right here to this switch. Right now it's 12 volts and 12 volts. It's got the same voltage on each side, so on our meter it says 0. But when we turn the switch on and the little light lights up, our meter goes to 0.02. That's your voltage drop right there. That is how you measure voltage drop, from here to there. If you want to measure it across the switch, you can move it over, and now you're measuring from the battery across that wire and across the switch. And as you see, we have 0.03 voltage drop. So essentially, that's all it is. If you want to move it further down the circuit, the further you move it down the circuit, you can move it right over here to the ground. This goes through the light and everything. So if you move it to the ground and through the light, your light is using all the voltage, 12.23 volts. But when you measure across here like this, that's your voltage drop. No math, no figure this, that, or the other. From here to there, multimeter on volts, that's your voltage drop. That's the difference between here, between right here and right here. That's all voltage drop is the difference in voltage from this point to that point. It's just a resistance check with voltage. It's more accurate because you have voltage flowing through it. You can ohm check something and it not turn out, but with a voltage check, like you can ohm a wire. If we ohm this wire from here to there, put ohms on it, it's 0.1 ohms, which this is a good wire. And if you jump it to the other side, you're going to have an open, obviously, because the switch is off. Turn the switch back on. 153 ohms. If you do that with voltage going through it, that's a voltage drop test. is voltage through the wire, the difference in the voltage. Like I said, it's the same as an ohm test, because when you do an ohm test, when you do a resistance check, you got your wire here. We'll say that's the wire, and your electric flowing through here. Say it's got corrosion here. Well, an ohm test just puts a little bit of electric to it, so it can come through here and go right to your end. But when full electric's through it, it hits here and that stops, so you're only getting this much of your full electric out. That's all it is. It's more reliable than a resistance check, and it's not as complicated as it's made out to be. So, hope this helps.